So, good morning everyone, especially to you, sir. And for today, we will be talking about Nature's Number, a book by Ian Stewart. Chapter 7 to be specific, and this chapter is called The Rhythm of Life. So, let's begin. Sorry in advance, sir, because throughout the video, I will be looking at my script, which is on my phone. And rather than putting it near the camera, I would just rather hold it and read, because it defeats the purpose of eye contact while explaining to you. So for the viewers, I would just rather hold it near me and read my summarization of chapter 7 while explaining the details or the missing part of my summarization. So to begin with, most of the chapter is all about gait analysis. It is a branch of mathematical biology that grew up around the questions: how do animals move? And why do they move like that? To introduce a little more variety, the rest is about rhythmic patterns that occur in the entire animal kingdom. One example being the movement of a cheetah that is hunting its prey. And although biological interactions that take place in individual animals are very different from those that take place in populations of animals, there is an underlying mathematical unity, and one of the messages of this chapter is that the same general mathematical concepts can apply on many different levels and to many different things. Nature respects this unity and makes good use of it. The organizing principles behind many such biological cycles is in the mathematical concept of an oscillator. And you may ask, what is oscillator? So, oscillation is the process of moving back and forth regularly, like the oscillation of a fan. Like you see, it's moving back and forth. Or the oscillation of a movie plot that makes you laugh and cry. Oscillation is from the Latin word oscillare, for to swing. So, oscillation is when something is swinging back and forth. Biology hooks together huge circuits of oscillators, which interact with each other to create complex patterns of behavior, such as coupled oscillator networks, are the unifying theme of this chapter. You may ask question, why do systems oscillate at all? The answer is that this is the simplest thing you can do if you don't want or are not allowed to remain still. Why does a caged tiger pace up and down? Its motion results from a combination of two constraints. First, it feels restless and does not wish to sit still. Second, it is confined within the cage and cannot simply disappear over the nearest hill. The simplest thing you can do when you have to move but can't escape altogether is to oscillate. Of course, there is nothing that forces the oscillation to repeat a regular rhythm. The tiger is free to follow an irregular path around the cage. But the simplest option, and therefore the one most likely to arise in nature, is both in mathematics and in nature, is to find some series of motions that works and repeat it over and over and over again. And that is what we mean by periodic oscillation. So that is my own understanding of the chapter 7 on Ian Stewart's book. I hope that me reading to my script did not affect the education that I gave to you, or it did not affect the way I communicate. So thank you all for watching this video and have a good day.